Okay, so this is going to be the video on significant figures. I'm going to go over the PowerPoint on significant figures. So let's look at present the entire screen and share this. And we are to this one, slideshow from the beginning. So here we go, significant figures, or also known as sig figs. So let's get this out of the way so that we don't need to worry about that. So here we go. Numbers in science, they convey information. So when we have numbers in our measurements, they are using the place of those numbers actually tells us about the measurements that we were taking. So science uses numbers to convey information about measurements. So we have to look at some rules because those numbers mean something. Hence, they're significant. So here's the rule number one. All non-zero numbers are always significant. So if you have something that's not a zero, it's always going to be a significant figure. So 58 centimeters, that's a measurement, 2 sig figs. 29.4 is 3 sig figs, 1.23 is 3 sig figs, and 48,762 milliliters, that's 5 sig figs. Rule number two, all zeros that are between significant figures are always significant. So since the 5 and the 8 are significant, I call this like the Oreo rule. Since the 5 and the 8 are significant in 5,008 centimeters, then that means those zeros are also significant. If we have 209.04 grams, then the 2, the 9, and the 4 are all significant, so therefore the zeros are also significant. So that's 5 sig figs. And then 120.3 seconds, well, all of those are significant. That 0 has to be significant because it's in between two non-zero numbers. And the same thing with the last one. There's 9 sig figs, so all those zeros, since they are in between real numbers that are 1 through 9, they are significant also. Rule number 3, leading zeros. Leading zeros are never significant. So leading zeros are always going to be to the left of the number. So a 0.58 centimeters. That 0 is not significant. Or it can be after a decimal, it's 0.0294 grams. Well, that is not significant. Those zeros are not significant, so it's only 3. This number only has 5. It's just these 5 non-zero numbers. All those are to the left of the number. They are insignificant. They are not significant, so they don't count towards your sig figs. They're just placeholders. They just go ahead and tell you holding a place so that when you get to this 1, you know actually what place value it is in. And same with the last one, leading zeros, not significant, so it only has 3. Trailing zeros can be significant, but also they may not be significant. So we have to have kind of 2 rules for this. So trailing zeros are going to be zeros that are to the right of the number. So if there is no decimal point, then a trailing 0 is not significant. So 580 only has 2 sig figs. 29,400, no decimal point, only has 3 sig figs. This one only has 4 because these 3 zeros, there's no decimal point. Now this one actually should only have 2, so that is a mistake. My secretary made a mistake right there. That should be 2 sig figs for this final one. Those zeros are not significant because there's no decimal point. Now, if there is a decimal point, then trailing zeros become significant. So 580 with a decimal point, that means that decimal point, we've taken time to write the decimal point, so therefore it now has 3 sig figs. 29.400 grams. There's a decimal point. The 2 zeros are to the right of the number, not just to the right of the decimal, but to the right of the number. Then that is 5 sig figs. And then we have 1.230000 seconds, that would have 7. All of these zeros are significant because there was a decimal point and they are to the right of the number. And then 76.20, that has 4 sig figs. So if we're looking at these examples, 4.30 or 390, well, you go ahead, you kind of pause this, take your time, and see. I will write it down, and then I will come back and I will give you the answers. Okay, hopefully you've paused it and you've gone through those. So this one is, there should be 4 sig figs. There is a decimal, so a trailing 0, the 0 to the right, is significant. The second one, 0.00872 seconds. So the second one should have 3. These are leading zeros. They are not significant. This one should have 6. They are all significant. These zeros are significant because they're in between non-zero numbers. And then these are to the right of the number, and there is a decimal point, so they are significant. Oh, here's a tricky one. Notice that this has leading zeros. Those are not significant ever. Even though they're after the decimal, that is not the rule. The rule is if it's after or to the right of the number. So 40810, that has 5 sig figs. Those are your 5 significant figures, not these 3. And then this one, we're going to count the 5, the 8, these 2 zeros in between the 8 and the 9, and we'll count the 9 and the 3. We don't count these last 2. So that should have 6 sig figs. This one, since there are no zeros, we don't have to worry about it. So that has 5 sig figs. And then this one, if it's in scientific notation, just drop off the scientific notation and look at just the number, the decimal number, 894.00. Those are significant, so that has 5. Don't let this scientific notation times 10 to the 5th change anything. It's always written so that you can count the sig figs based on the number, the decimal that is written. Now, we do have problems with trailing zeros. Like we can have this measurement, and we know that it has 5 sig figs, but how could we do this? If we put a decimal at the end, that makes all of these zeros significant. So what we can do is we can put a line over the last significant 0, so 4, 5, and then 3 zeros. So put a line over that. That makes that 0 significant. And by definition, if you have zeros that are in between significant figures, they become significant. So these 2 become significant. You might see it written as 45000 with a line under it, because sometimes it's hard if you're writing or typing stuff. It's hard to get the line over the 0. So just put a line under it. Scientific notation, that is like the best way. We can write it in scientific notation. So we take the decimal, we move the decimal, make it between 1 and 10, so 4.5000, and then we have to count how many times we move that decimal. 1, 2, 3, 4, 5, 6, 7, so that'd be times 10 to the 7. If you move your decimal to the left, then the superscript goes up. If you move your decimal to the right, your superscript goes down. We cannot do this and add the decimal at the end because they're not all significant. It only would work if they have 8 sig figs. So you might find that confusing. So if you do, this is a better way. This is like an easier way. The thing you have to know is you have to know a map of the United States, and you have to know which oceans are on the East Coast and the West Coast. And then you have to also be able to identify a decimal point. So it's called the Atlantic Pacific Rule. So it looks at the absence or the presence of a decimal point to determine the number of significant figures. So this is why the United States is the greatest country, because it works for the United States. It does not work for necessarily other countries. So we're going to look at this, and oh, look, right there by Chicago. See where Chicago is? That's kind of where Batavia is. We could zoom in, and you could be seeing like where you live right in Batavia. Okay, look at the decimal point. If the decimal point is absent, that means it's not there. We're going to start from the Atlantic Ocean and pretend that we're in an airplane traveling to the left. or going west over the United States. We'll move across each number going from right to left. And then once we come to the first non-zero number, we start counting. We'll proceed to count all numbers, including zeros, once we start counting. So we look at this. If the decimal is absent, we start over here on the Atlantic side, and we start counting from right to left, and we start counting at the first non-zero number. So if we look at this, here's one, no decimal point, so it's absent. Absent starts with A, Atlantic starts with A. So then we start counting, oh, that's not a non-zero, that's not a non-zero. The 8 is a non-zero, so we start counting there, and we count all the way to the end. Oh, there's only one sig fig. The second one, no decimal point, so we start counting from the Atlantic side, start counting at the 6 because that's a non-zero number, and then we count everything until we get done. So that would have 3 sig figs. For this one, we see that there's a 0. There's no decimal point, so we don't count the 0, but we start at the 9, and then we count 2, 3, 4. So that should have 4 sig figs. And then if we have this for microseconds, then we don't count these 2 zeros. There's no decimal point. So we count from the right to the left and start counting at the first non-zero number. So 1, 2, 3, 4, 5. Tells you what you get. And there you go. Now the next one. If the decimal point is present, then we're going to start from the Pacific side. Notice that present starts with a P, Pacific starts with a P. And we're going to do the same thing, and we're going to count in the opposite direction, going from left to right. Here's your problems. So we got a decimal point. The decimal point is present, so we start from the Pacific side on the left, and you start counting at the first non-zero number. So we count the 8, we count the 0, count the 0. So this now has 3 sig figs. For this next one, we would have 4 sig figs because we start from the left, count the 4, and then count all the way to the end, including zeros. Same thing with this one. We count starting at the 1, 13.090, and we start counting at the 1, and we count the 1, the 3, the 0, the 9, and we do count this 0 because we count all the way to the end. And then this last one should have 1, 2, 3, 4, 5, 6, 7 sig figs because we include these because we start counting from the left to the right because the decimal point is present. And then this tells us, yes, was I right? 3, 4, 5, and 7. I think I was. So try this, pause this for a second, and then I will go over it. So pause it. Okay, so you should have paused it. So look at this, decimal points absent, so that should only have 2. We start counting from the Atlantic side. This one, there's a decimal point, so we start counting from the Pacific side or the left, so that one should have 7. This one, the decimal point is present. We start from the left. We don't count these leading zeros, and that only has 3. We start counting at the 3 all the way to the end, including those zeros. This one, no decimal point, so we don't count this 0. We start counting from the right, 3. This one, no decimal point. Once again, we start counting from the right, has 3 sig figs. This one, let's see, that should have 7 sig figs, and this last one should have 3 sig figs because the leading zeros are never significant. We start counting from the left. We don't count those zeros. Here we started counting from the left. We counted the 5 all the way to the end. That should be stop presenting. That should be sig figs. Next PowerPoint is going to be calculating with sig figs. So look for that one next.